Our video today is going to cover curve fitting and regression. We're going to be looking at three specific types of regression here. It's going to be linear, quadratic, and exponential, though we're only going to see examples for the first two. The third one is one that will follow the exact same trend when we go through the process. Before we do this, we need to go and cover a couple things before we actually get into figuring out how do we fit lines and curves into sets of data and how do we actually do regression with this. So we want to first and foremost define what a scatter plot is. And a scatter plot isn't anything particularly advanced. It's a set of axes like we use for graphing, and it's just dots and points within there based on a set of data given to us. The key distinction between a scatter plot and a quote-unquote standard graph is that none of the dots and the points are connected together, hence the scatter part of the scatter plot, which makes sense. Now what we are going to do is then use that scatter plot to tell us what the information and the data we've been looking at tells us about any trends in the data set or information that we've been given. So based on those, as we have here, we want to look for patterns and say, does the data in the scatter plot look linear, quadratic, or exponential in nature? And some quick reminders on what those tend to look like. Linear ones, the data is going to look kind of, maybe it's going up, maybe it's going down, maybe it's very steep, maybe it's very shallow. It'll vary a little bit depending on the data set and what that looks like. The quadratic style of information is one that we see generally in our later algebra classes, but this is one that looks parabolic in nature. It's the U, or it's the upside down U graph. And again, there's some variation that you'll see with these, but these are just broad stroke generalities of what these data models look like. And exponential graphs generally tend to be very flat and then grow very, very quickly, eventually at some point in the set of data that we've been given. So these are the main things that we are going to be looking for and the trends that we should be expecting in the sets of data that we're looking at. There are significantly more advanced versions of regression and other types and graphs that we can find, but for the purposes of this video today, we're just going to look at linear, quadratic, and exponential, though the process to find the other ones is going to be fairly similar. So as necessary throughout this video, I highly recommend pausing it and writing things down. There's a lot that I've written in here and I've typed in, and I'm trying to make this as universally compatible as possible. But because we are using a graphing calculator and there's like 80 different kinds of graphing calculators, probably more like 5 or 6, but 80 gets the point across. With so much variability, it's hard to make a universal, here's how you're going to be able to make this work for every single one of your calculators. Now I am going to model all of these different steps that we have in a graphing calculator app that I'll be using, but again, as necessary when we're talking through this here, please pause the video and write any and everything down that you see fit. I'm going to try and highlight stuff that I think is worth noting, some warnings and things like that as necessary. So let's dive into it. Let's start with our first kind of our main points that we're looking at over here for our overall process. The first thing that we want to do with a set of data to do curve fitting is we want to input that data. This is by far the most important and essential steps or set of steps in the entire process. If anything goes wrong when you are inputting the data, any and everything else that you do will fall apart, and it's just you throw the problem out, start over again as necessary. It will absolutely destroy everything if something is even slightly off. That means any and every decimal point, any and every negative sign, zero, extra zero, anything like that needs to be entered in perfectly. So we have over here the methods that we're going to be using to do that. We have the button sequences listed right here. And again, all of this is what we are going to be going through in the actual calculator itself. So if you'd like to pause it and write any of these down, you're welcome to do so. The one thing that I will note, and I would recommend putting, if you got a highlighter or red pen or something like that, I'd put a little star right by this guy here. when we are going through and deleting data in sets of columns that we have, and we'll see those here in a little bit, do not hit the del key in the graphing calculator. It's also known as the delete key. What that will do is delete an entire column of data, and the only ways to get that back, best that I have been able to found, is by resetting the entire calculator. You could probably find some different methods to reset and put that particular list back into your calculator through different YouTube videos, but the best way that I've found to work with all the different graphing calculator types that I've seen is the universal reset your entire calculator button or button sequence, which I wouldn't recommend doing if you have extra preset things and stuff in there. So we try and avoid that if we can. So we're going to input all of our data into the calculator. Great, it's all in there, perfectly good to go. The next thing that we want to do is actually view this data. Again, we want to see what the scatter plot tells us. Does this thing look more linear? Does it look more quadratic? Does it look more exponential? What am I looking at? So we're going to go in and then we are going to actually view the given data on the scatter plot in the graph area. This is going to give us way to look at this, and we've got some different tools that we'll see to adjust the window and zoom this thing in and out to view all of the data that we've been given. The big thing that we want to do with viewing this data is determine if it's linear, parabolic, or quadratic, or if it's exponential in nature. That's all that this step is doing. We visualize the data that's been given to us. The third step is where we're actually going to calculate the regression, and by calculate, I mean the calculator is going to do all of that heavy lifting for us. So once we've determined which of our three types of regressions we're going to need to be doing, we're going to follow one of the three potential button sequences that's listed here to actually go through and tell the calculator to do it. I should note you might have some slight differences in these button sequences, specifically these last few steps, depending on the version of the calculator that you are using, but you should use the first three the exact same way as what we have listed here. This is where you tell the calculator, hey, given this data, do a linear regression, do a quadratic regression, do an exponential regression, blah, 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 blah. It does all of its advanced computing, and it will spit out an answer for you. The last thing that we want to do, which is generally good practice with these things, is actually write out the regression equation. The calculator is going to give us a screen that's going to have a bunch of extra data in there, and we are just looking for what are the specific A, B, sometimes C values necessary to plug in and just create that regression equation for us. For the purposes of this video, if you do see R and R squared showing up, we are going to disregard those at this time. Those are relevant to later statistics classes and statistical modeling that we use. But for the purposes of what we are doing here today, we can ignore those. We're going to just say that's for a later class. We're not going to worry about that. So once we have our best fit equation or our linear regression or quadratic regression equation, we can pretty much do kind of whatever we want with that. We could find x and y intercepts, we could interpret values and slopes, we could find values in ordered pairs based on the line that we create. I recommend using a calculator for all of this number crunching. You will see very quickly that these decimals get gross and terrible. So yeah, let's let the calculator do a lot of that heavy lifting for us. The last note that I want to make with all regressions, whether it be linear, quadratic, exponential, this class or a future math class that you're taking, maybe a more statistics heavy class, regressions by their nature are not exact, but they give estimated equations based on the data given to them. We can think of this with a general model example of, in the real world, we generally tend to see XYZ things happen. We are never going to ever see a study that this tells us a perfect one-to-one representation of how things are always and forever going to go. But we have data that indicates and is pretty accurate to tell us what an outcome is going to be. So regressions, and as we are looking at these things, if you try plugging in numbers and answers seem slightly off, and they don't entirely make perfect sense with what we have and the data we've been given, that's okay. This is normal. This is expected. This is just the nature of regressions in general. Okay? Let's assume we don't see these here, forgot to cover these up, but hey, those are the spoilers to the problems that we're going to be seeing here. Now, before we jump over and take a look at plugging these things into the calculator, we do have 3 examples. And again, I'd recommend pausing the video as necessary to write these sets of data down for yourself. I guess I can only get 2 in here at a time. So for each of these sets of data, we are going to determine a best fit line that matches this. We're going to round all of our answers and decimals to 3 decimal places at the very end. So our first example is listed here. Our second example is listed here. And our third example is listed here. Again, I'm going to jump over to an app that just shows and displays a graphing calculator, but when I'm referencing example 1, example 2, example 3, these are the 3 examples that I'm working with. So again, as necessary, before we jump over there, I would recommend pausing the video and writing these down for yourself as I'm referencing these examples. I'm going to see if I can, hey, there we go. Got the screen to show this a little bit better. So pause here is necessary if you need to write these down. And we're going to jump over to a graphing calculator app and actually go through how to enter these things and have the calculator do these regressions for us. So here we are with our graphing calculator. We're right here at the home screen. So hopefully you have the first example written down somewhere nearby for yourself, because we're going to go through how to get that entered in and do a regression with that set of data. So as listed in our notes, we need to first and foremost input this data into the calculator. This is the most essential set of steps. We need to double, triple, quadruple check that everything is entered in correctly, because this will make or break everything that we do. So what we're doing is on our calculator, we're going over here to the stat option that's right next to the alpha key, clicking on stat. At the very top, we should be under the edit tab. We're going to go into the first edit option, this edit ... right here. You can either hit the number 1 or you can hit enter. I'm going to hit enter here. And here we should see list 1, list 2, maybe you see list 3, 4, and 5. Your graphing calculator might look a little bit different than mine, but it should look similar enough in this regard. Now I'm seeing here I've got sets of data listed in here. I'm going to go ahead and get rid of those. So as listed in our directions that we had, we're going to go up to the very top of these 2 lists. I'm using the up, down, left, right, the D-pad. Here, I'm going up to the top. I'm going to hit the clear option, and I'm going to hit enter, and that clears that list. I'm doing the same thing, going over to list 2, hitting clear, and then hitting enter, and now I have my first 2 lists cleared out. I would recommend, if necessary, scroll left and right to make sure that you have all of those lists cleared out, and we are only going to use our first 2 here. I think that tends to help cut down on potential confusions with the calculator and other things that we can do with it. So we're just going to keep everything to our list 1 and list 2 for these examples. Now looking at our set of data, what we want to do is input all of the input values, in this case x, into our first column, and all of the output values into list 2. Those are our y values that we have here. So input values to list 1, output values to list 2. Do not change or edit the order that those are entered in. Just enter it in exactly as it's been given to you, and just click away at that. So we're coming down to this one. We're hitting 1, enter, 2, enter, 3, enter, 4, 5, 6, 7, and 8. Now again, we should double check. We have 1, 2, 3, 4, 5, 6, 7, 8. What does our data say? I'm looking at it on a different screen here, and yes, it's the same thing, so we're good there. So let's jump over to our output values. These tend to take a little bit longer if we have more complex stuff, but we're doing this all the same. 1 has an output value of 20.7. Then we have 19.1, 16, 13.9, 10.3, 8.0, 3.1, and negative 1.2. Quick note here with this negative. Do not hit the subtraction key over here. That is going to give you errors showing up. We are trying to enter in a negative to tell us that we have a negative number. So we want to hit this little parenthesis with the negative down here. Negative 1.2. Make sure you're double checking yourself on that. A good chunk of people tend to hit the subtraction sign, and that gives us syntax errors and things like that showing up. You might get an error showing up on your screen if that happens. So remember, button down here is for negative numbers, not this one. Again, we're double checking everything is entered in correctly, and it looks like it is. You might be wondering, looking at this 6.8, well, the data set that was given says 8.0, but the graphing calculator just makes it a single 8 here. Yeah, it does that. Nothing wrong with that. That's just how it operates. Some people freak out about that being slightly different, and while it's good to make sure that we're taking care of this, if that's the difference that the calculator does, we don't really have anything to worry about there. So fantastic. All of our data is entered in correctly. We can now go back to the home screen. So we're going to do that by going over to Second, and then Mode. That second Mode button makes us do Quit, and it puts us back to the home screen. It's kind of our universal Go Home key. Now that we have all of the data entered in, we want to actually view this and see, what does this look like? Is this linear? Is this quadratic? Is this exponential? So to view this data, we are going to go up to the y equals section of our calculator. If you have any equations written in here, I'd recommend using the up and down arrows to select those, and then the clear button to clear any of those out. We don't want any extra random graphs or data in there that might distract us from what we're actually doing. Once all of that is cleared out, we are going to go up to the very top here, and we want to enable plot 1. This tells the graphing calculator, hey, I want to create a scatter plot using the first two columns that we have. Technically, there are other ways, depending on the version of calculator that you have, to do 2 or 3 scatter plots at once. I think that gets very confusing, so we're going to stick with just doing plot 1. So I scroll up to plot 1. I'm going to then hit enter, and we should see a little, now this thing has a black background around it. This has enabled the calculator to plot the scatter plot of data that we entered into that stat key. So fantastic, let's go take a look at this and see what it looks like. So we're going to hit graph here. And if you're getting something that looks similar to this, you'd be thinking, wait a minute, we entered a whole lot more data than just these 3 data points. Yeah, that's because, well, this thing is set to its automatic and standard zoom lengths. Maybe yours is set to a previously set one, and you're seeing even less than I am right now. So the way we can work with this is we are instead going to come up to the zoom option in the middle. We're going to scroll all the way down to this option 9 here. It might not be visible on your specific calculator at this time, but we scroll down to zoom stat. This tells the calculator, adjust the zoom to fit the statistical plot that I have set up here. So go ahead and scroll down to that. We can either hit 9 or enter. I'd be a little careful with hitting 9 just in case you have a different graphing calculator and zoom stat is at a different number. But once we have that, we're going to hit enter. There we go. Now we're seeing our set of data. It's just points that are displayed there. And we ask ourselves, does this look linear in nature, more like a straight line? Or does it look more parabolic in nature? Or does it look exponential in nature? Now again, scatter plots aren't always going to be perfect representations of those 3 types of graphs and other ones that we see, but which one does it most accurately look similar to? And in this case, I would say this thing looks more accurately like it's linear. It's obviously not perfect. It kind of is moving down. It seems to almost kind of a bump here, and then it goes back down, maybe another little bump, and then it dips below. But this thing looks pretty linear in nature. So somewhere nearby, I would recommend writing down for yourself linear, just so we know that data set 1 looks like it's going to be and use a linear regression. Excellent. Now that we've seen that, let's back out and start actually doing a regression. So I'm going to second mode, back out to the home screen. Now to actually go in and have the calculator do this regression, we're going to go back to the stat button here. We're going to scroll over to the calc setting at the top, or the calc tab at the top, I should say. I'm going to use the directional pad here, going over to calc, and then I'm going to go down and select the linreg, linear regression here. There are technically two versions of these. They calculate the exact same thing. I would recommend using this one because this is closer to being in our slope-intercept form, the y equals mx plus b. It just has that x value in front. If you'd like to use the one down here, you're welcome to. I also think it's just the first one we get to, so why not use that? So we're going to go scroll down and have it perform a linear regression for us. Go ahead and hit enter. And this is where you might have some deviations with what's showing up on the screen. Some people might see something like this, where we're told the X list is list 1, the Y list is list 2. This is why we enter in the input values for list 1, output values for list 2. The calculator automatically defaults to having the sets of data set up like this. So if you make that your habit as you're plugging these things in and solving for them, you're not going to have much to worry about here. That says it needs to be. That says it needs to be. Great, I can scroll down to calculate and get to my answer. Other people might just have linreg showing up on their screen depending on the version of calculator that they have. If that's the case that you're in, there's not much more that you can do from there. You would just hit the enter button. If you have a screen like this, we scroll down to calculate and then we're going to hit enter. We don't care about frequency list. We don't care about storing a regression equation for right now. That's going to be, again, saved for later statistics classes. So down to calculate, I hit enter, and I see stuff showing up here. Hey, I don't have the r and the r squared showing up. That's kind of nice. So I now see y equals ax plus b. The calculator is telling me that my a value for this linear regression is going to be negative 3.10595238. The decimal points go on for a very longer ways beyond this. And this is where we need to make sure that we are checking how are we being asked to round these things. We were told to round our answers to 3 decimal places. So this a value, the thing in front, is going to be negative 3.106. I'm going to round here, which means I need to look 1 over. That number is 5 or greater. This 5 rounds up to a 6. So my a value is negative 3.106. My b value is going to be 25.214. And there I would have my overall linear regression for my first example. Let's take a look at our second set of data. We're again back at our home screen here. Now, first example took a little bit longer. I wanted to make sure that we're going through and tracking every single part of the button sequence. We're going to try and do things a little bit faster here with our second and third examples. Again, you're welcome to pause the video, go back, speed it up, slow it down, whatever you need to. But we're going to try and go through this one a little bit more pace so we're not sitting here with an hour-long video. So for our second example, again, we need to go up and we need to input all of the data that's been given to us. So I'm going to go over to Stat, making sure I'm in the Edit tab, go into the first Edit option here. I'm going to clear everything out in these columns, and I'm going to input all of the data in that second data set. I'm then going to double check and make sure all of my input values and output values align with one another exactly as it was given to me in my set of data. And it looks accurate there, so we're good to go with that. Let's go ahead and jump ahead to viewing this set of data. So we're going second mode, back to the home screen. We're going up to y equals. Make sure everything is cleared out. We're good there. I still have plot 1 enabled from previous times, so we're good with that. And let's go ahead and take a look at this graph. And again, we're only seeing 3 of our data points here. Well, this is because the window is still set to what it previously was on our last time we did a regression. So we need to go in and readjust it for this round. So I'm going up to Zoom, going down to option 9, or 9 about, should be right around there. Now, there we go. Now I can see everything. And again, we're looking at this data and it's a little bumpier this time. It looks even less perfect or less straight than our previous one. But again, we're asking ourselves, does this data look more linear in nature? Does it look parabolic in nature? Kind of the U or upside down U? Or does it look exponential? It's flat, flat, and then it just spikes and goes really steep later on. And this again looks fairly linear in nature, so we are going to do a linear regression with this thing. Fantastic. So we'll go back to the home screen. We're going to go in and do the actual calculating of the regression. So we're going to click on Stat. We're going to go over to the Calc option. We're going to then go down again to Linear Regression. The X list is list 1, perfect. The Y list is list 2, excellent. We don't care about frequency lists. We don't care about storing this thing. We're going to go down to Calculate. And there we go. There's our linear regression here. Y equals AX plus B. They use A instead of M compared to what we normally use, but that's fine. So if we're rounding to 3 decimal places, the value in front here should be 1.215. Remember, this is less than 5, so I'm rounding down, cutting this stuff off, and just keeping these first 3 here. My B value is going to be negative 2.591. Again, rounding down because this value right beyond the 3rd decimal place is less than 5. And there we would have our linear regression for the second set of data. Looking at our third and final set of data, we're going to go through and enter this in and do a regression for that as well. So back here at our home screen, we're going back up to inputting our data, clicking on Stat, Edit, Edit. Again, I have sets of data here. I need to clear these out and then input the data set that I have been given. Now that we have the data entered, we can go through and view this thing again. Remember down here with our negative, we are always clicking the negative button, not the subtraction key. If you had an error show up, that's probably because we hit the subtraction key. We need to make sure we're hitting the negative one if we're just entering in a negative number. So let's jump over to viewing this data. I'm going up to y equals, still have my scatter plot enabled. All of these are cleared out still, fantastic. Let's take a look at this graph. And hey, it turns out the window that we used previously actually still works pretty nicely here to show all of our data. If you still want to be thorough and make sure that we have everything listed, we can still go over to Zoom Stat. Let's take a look at that and see if that adjusts things at all. Yeah, not a whole lot, but at least a little bit. So again, we're asking ourselves, does this thing look linear in nature, like it's similar to a straight line? Does it look like it's parabolic / quadratic in nature, more like a U or an upside down U? Or does it look exponential, where it's flat and then it goes super steep? And this doesn't look perfect, but it looks more like it's quadratic in nature in some way, shape, and form. Again, far from perfect. These are just estimates that we have, but that's the best that we can go on. And this tells us that, for example, 3, we're going to have to do a quadratic regression. Fantastic. Let's jump over and do that. In second mode, go back to our home screen, and then going over to Stat, coming over to the Calc tab, and I'm doing a quadratic regression. So I believe, as the notes stated, this would be coming down to quadrag here. I had made the notes with a previous version of a calculator, so again, these numbers that are listed on the side might be different from what you have, so look for the title of the command versus the numbers themselves. The numbers should be close, but they're not exactly perfect. So here we have a quadratic regression. That's what we are looking for. We're going to go ahead and hit enter. And again, we have the same X list, Y list, inputs, outputs. If we follow that pattern, we don't really care about this. This is exactly as it needs to be. We're going to go down to calculate and then hit enter. Now, should be noted, with the quadratic regression, it lists things in standard form for quadratic equations, this ax squared plus bx plus c. And again, we've been given our a, b, and c values here. We were told to round our final answer to 3 decimal places, so my a value is going to be negative 0.276. Number here is 5 or greater, so I round this up. My b value is going to be 4.528, less than 5, so I'm rounding down. And my c value is going to be negative 7.665. Number here is 5 or greater, so I need to round this thing up. And there I would have my quadratic equation for the third example. The last part I do want to show, just because it does happen sometimes, and so therefore I want to get you the solution to get out of this if it does take place, is if we come in and we are editing our list of data, and maybe we accidentally go up and we delete an entire list. Now I have list 1, list 3, 4, 5, 6, but I've completely deleted list 2 and it's gone entirely. If this happens, one of the routes that you can take, and the again, best that I have found, universal way to bring back list 2 is to reset the entire calculator. So we're going second mode, coming back to our home screen, which means we are going to lose any and all extra equations or programs or things that you have calculated and put into your calculator. But this is going to guarantee that we're going to get that list back. Again, there's probably other methods you can use. You're welcome to Google them or YouTube them, but it might vary a little bit on a calculator by calculator basis. So this is the kind of nuclear option for all of them, but you're welcome to explore and find others if need be. Or we don't have this happen and then, don't have to worry about it. So we're clicking on the second memory option. This tells us everything we have memorized in the calculator has in it. We are going to go down to this reset option here. I'm going to click on enter. We want to make sure that we are doing this and resetting all the RAM. It's going to ask us, are we really sure that we want to? All data and programs are going to be erased. Yes, that's what we need to do to get rid of the stuff that's missing and get the stuff that is missing back in place. I'm going to hit reset. And hey, here we go. Here's everything that we had now. Let's go back into our list and see what happened. I click on stat, going into edit, and everything's been cleared out from list 1, and if we had anything else, it would be cleared out as well. And we have our list 2 back. The other thing that I wanted to note as well is if we have our graph set up, maybe things were previously set, I think we were over in this area with the graph options that we had. If you ever want to reset the graphing window that you have back to the original thing, we're going to come up to zoom, and we're going to go down to Z standard. It should be option 6 on most calculators. But that tells the calculator zoom standard, the standard box that we have this thing set up to. So we're going to scroll down to option 6 and hit enter. And hey, we look at this and it doesn't look like it's really changed anything. Well, that's also because we just reset the entire memory on it, but it would and should reset everything back to its main standard settings and window and dimensions and all of that. So just a couple extra things I wanted to note to you guys if something comes up with a calculator, and extra handy zoom tool when you're working with other graphing stuff and wanting to reset windows. So as a quick wrap up and review and summary of what we went through here today with our curve fitting and regression, we went through how to input that data into our graphing calculator, remembering that we are not hitting the delete key to clear lists. We're then viewing that data to determine if the information looks linear in nature, quadratic, or parabolic in nature, or exponential in nature like we see here. We can use the zoom stat key to help us adjust the window to see the data a bit more clearly, and I recommend we do that on a problem by problem basis. We're then going to go in and actually calculate the regression, or better, the calculator is going to calculate the regression. And that all determines if I'm doing a linear, quadratic, or exponential based on the data that I've seen. We have our options listed here. Again, these numbers might vary ever so slightly based on the version of calculator that you have, but the command that's listed here should be the same on pretty much all of them. I know we didn't go through an exponential regression here, but the process that we used previously and up to here is going to follow the exact same steps that we used. And then last but not least, we're going to write a regression equation out, substituting A, B, maybe there's a C that shows up in there accordingly for the equation that's been given to us. And again, for the purposes of our class and what we're covering here, we are not going to care about r and r squared at this time. If that shows up on your calculator, that's fine, we can ignore it. It didn't show up on the ones that I went through, which, yay, great, it didn't. We'd be ignoring it all the same. We had our answers to our 3 examples that were listed down here. Again, just as a reminder for our 3 data sets, hey, there we go. Able to get all 3 of those fit in to this page right here. So hopefully this was pretty helpful with how to get these set up, how to write them out and enter them into the calculator. Again, as necessary, scroll back up and, well, at least go back in the video, I should say. Or I'll scroll back up here. And if you need to, pause the video, write all of these down for yourself. I think that's very much worthwhile doing. This looks like and seems like there's a lot going on with it. I tend to find once we do it a few times on our own, it gets pretty repetitive and kind of mechanical and not too terrible after that.